Okay, well, welcome back, everyone. Welcome, Jason. Hi, how are you doing?
Peter, I am very well.
We're having fun this week, aren't we? We've had a chance to introduce our explorers to Global Math Week. Um,
Because it was quite good that everyone remembered it
Last year,
last year.
and we had James Tanton very
Wow,
kindly visit and
that was
share
amazing.
his session.
Hmm. And yeah, so that we had people as soon as they heard it jump off and start doing exploding dots and things like that. So that's always good when maths has that when something has that impact, on kids and their maths. It,
Absolutely. They headed straight for the website. And we were like, hey guys, come back
yeah,
virtually, come back to us, and the website will be there to explode your dots. So we
mm,
picked up again on it this year, but with
absolutely.
a different, let's call it machine or game,
Yeah,
how we
so
presented it.
I thought it's so there's an ambassador talk. So I think I may be mispronouncing his name, but Kiran Bach, and he's from DMaths.
Mm.
And we'll put all of the details for that in the notes. And yeah, so he's got another machine that works in a different way. It works in a similar-ish way, but it works differently to exploding dots. And that was kind of cool because we had those kind of I'm not going to call them misconceptions, but people I suppose taking the way that exploding dots works, especially on the 2-1 machine, where you get two dots in the same cell and they explode. So getting over that was,
Mm.
was quite interesting, but it happened. But it took some work to get over that. Maybe I'll share the machine. So I'm going to
That's
put
right.
that up on the screen. Let's see. This is more or less what the machine looks like. Of I've changed the colors slightly, but it's um it's the same machine that was shared by Kiran. And yeah, it was I thought this was such a such a an opportunity to explore. And but I have to say, this is what I thought so much more came out of it than we had planned.
Mm. I'm going to hold you there just to, we have a grid essentially on our screen, right, Jason, with on the right-hand side, kind of going up vertically, the numbers 1, 1, and more numbers going up to 34, and then horizontally as well, and then some colored boxes. But you were saying so much more came out. Let's hear your thoughts on what we saw happen this week.
Yeah, so one, I mean, this is I feel there's it's we've got a puzzle here in that, and it's not super obvious when you first see it what this machine will produce or what the cells mean or anything like that. There are little clues in there, like people can see the sequence. Maybe I don't know, should I give away what the sequence is? I mean, you can see the numbers
I
there.
think I think for this one, let's tell our listeners, yes.
There you go. All right, so do it. You're gonna have to do it. I can't. No.
You can't tell.
It, it's the Fibonacci sequence. Now, in lots of clubs, people saw that, and we had really sweet responses like, "Can I tell what Can I tell what the sequence is? I can see, giving little clues." And that came up a lot in this activity. That was just, it's such an honor to work with children. Anyway, but yeah, it was really lovely to see this worked. It really was an example of joyful maths. So yeah, we've got the Fibonacci sequence along the bottom. So what we've done this one up to 34, top and bottom, and yeah, so that's one thing. And then we've got our for the activity that we've done, especially kind of for now, we had just we kind of used, going along the horizontal axis, pretty much like exploding dots would do. In a 2-1 machine, you'd start on the right handmost box, and then the explosions would head to the left, and then the machine would become stable at some point. Now, in this one is a slightly different rule. So you can put more than one dot in a box, and you explode dots by jumping over them. Jumping over. So if you jump from the right side over a dot to the left of it, it will explode the dot you've jumped over. A bit like solitaire. If you know, not the card game, but the game where you're jumping over marbles often.
Yeah, marvels.
Yeah, so you can kind of start off with quite a few dots in different places. Let's say something like that. Maybe yeah. Let's say you've got something like that, and then you've got to jump your dots and see if you can get, the way we did it, see if you can get down to one dot in the end. And here I've got one more jump I can do, and then I'm kind of stuck. There might be there are still other things I could do here, of course, with my dots. We didn't really get into unexploding dots, but I could have, instead of what I did there, I could maybe unexplode a dot. And yeah, there'd be lots of other things you could do like that. So that was really cool. And yeah, I thought there was that opportunity to, there was the opportunity to really play with the ideas here. And as I said, I don't think that it was very obvious. I think we had one explorer who maybe saw most of the things that would happen almost immediately. But even then, managed to play with this idea a lot. So it really offered a lot for us to play with, I thought. The puzzle that we kind of had this week, it was especially nice because we started off with, I think we kind of explained how it worked, and that was like, if you've got a dot, you can jump over it, and the basic explosions idea.
And
Then
dots in the same color can move
yeah,
freely
they
between
can
their colors.
be in the same color. Yeah, that was the other rule.
Mhm.
We didn't get into anti-dots, of course, which but of course, explorers had questions. They noticed it and said, "Oh, I really want to
Hypothesize
know
their
about."
way
Yeah,
into what
absolutely.
they could possibly mean and went into science. And is it
Oh
like
yes,
matter and antimatter? And
yeah,
is it like,
antimatter, and so many discussions coming up
there's
about
so many
it.
discussions on that. And then someone just brought it down to no, it's like one and minus one. So they had their discussions on what could
And
this,
yeah, we had the holes and the mounds of Earth.
yeah,
That
yeah.
idea that, yeah, and if you take the mound of Earth and put it on a hole, it will just bring us back to. And I think that's one of James Tanton's ways of, because I've
It
seen that
might,
before.
it
Anyway,
might be.
there you go. So really great, just a way of getting people into it. It works so well. And so the puzzle we had was, if you start off with a certain number of dots here, let's say we start off with 3, can you explode it down to 1 dot? And so we had the examples where we'll do that explosion, and then this, excuse me, this explosion, and we'd end up with 1 dot. And of course, it was 3 dots to start off in all of the ones, and it ended up as 3. And we tasked, or we challenged our explorers to see if they, if they could get any number of dots down to 1. And from 1 to 9, I think, is what we suggested. And yeah, going through the activity brought up the questions to do with this grid, like, well, can I do this? And clarifying the examples. And yeah.
Are we allowed to go into the grey cells? Can we, we've got 2 red cells corner to corner. Can we still move freely within that?
Mm,
lots and lots of questions to clarify. We actually narrowed it initially, didn't we, to test out the numbers 1 to 9. Can each of those be exploded down to one dot if
mm,
you're starting with your little collection in the white cells? Um,
yeah.
and at some point, with our sort of don't reveal too quickly rule, we had a lovely collection in chat of not giving the game away, but it's something to do with the S dot 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 N
Yeah.
word, not a swear word. And then a discussion there as people did start spotting what they thought maybe couldn't be exploded down to one
Mm,
dot, and then disagreement as
yeah.
others were sure they could.
Yeah, no, this is it. And, so it kind of drawed out, it was a great way of drawing out some of the misconceptions and getting used to this grid or to this machine, shall we call it?
And as an offshoot, actually, on that, we had animations to, in part
Oh,
to show us to prove why a certain number could or could not be exploded down. So, those of you who don't know the digital whiteboard we're working with bit paper, the undo button can really set you up nicely to show kind of what looks like an animation by the end of kind of rapid undoing. And we had young people setting up animations to with explosions and images to show what they thought was happening, which was
yeah.
a whole different skill to what we thought would
I had to
get
have a bit of a
practice.
go at it in a minute or two, but yeah, it would work like this. So we'd go have it jumping over and exploding
Mm,
that one dot like that. They did it way better than we did, than I
way
just did.
better.
So much more clear.
um, so that generated discussion and creativity, and can we do this? Can't we not? But people spotted stuff as well, especially as they started getting into the grey cells and they were trying to reach out for links, perhaps, with what they saw earlier in the Fibonacci sequence. Others were just playing and seeing could they explode these dots.
Yeah, it was just lovely, really just lovely. And I suppose the kind of spoiler is that I suppose the way of thinking of it is that this machine kind of holds the number state. So if I start with this state, any valid movements I do will hold this number state, and it's like adding these numbers up. So if I add 2 + 3 + 5, whatever moves I do, if they're valid, should keep that number state. So I could unexplode a dot, for example, and that would bring me to there, and it should be the same. Or I could explode a dot there, and I should have the same amount. And then I could move that to there because that's a free move. I could explode a dot again, and at each of those, we've got the same number state here. So that's kind of one. And in each of those cases, we'll have dots in different positions in the grid, but every time those dots represent the same number. And I think
So
that
sometimes through addition, sometimes through multiplication.
um yeah, well, I guess the what each number is, each number on the cell is based on multiplication, but the dots, any dots that are together, any dots on the grid would be added up.
Mm,
So yeah, that dot
okay.
is there is 10 because of its place on the grid. Whereas if I were to come back here and I've got two dots in the yellow or in the 5 space, then we'd add those up to make the 5.
Mm, to make the 10.
So yeah.
Okay.
Um,
So
so yeah, really nice activity. And
thank you, Global Math,
uh,
and all contributors over the years to this movement for
mm,
making so much of this freely available for others to use and share with their students as well. We had fun, Jason. I think we're going to finish this off next week as well, maybe for now.
yeah,
we're
So
thinking with
we're
anti-dots
actually going to
and
look into, yeah, we're going to look into the challenges that that Kiran actually shared on his ambassador talk. So this is, we're getting into proofs now, actually proving certain things about whole sequences. So this is proper algebra that we're going to be doing with all of our groups. So it's going to be fantastic.
and as you say, all the links and support material will be in the notes.
Description,
If
yeah,
anyone's
show notes. I don't know exactly how that will happen, but it will happen, and they will be there.
okay.
I guess we could put an example of the board, that people could do
Mm,
offline if they want to print it
mm,
out
mm,
and play
mm.
around. So yeah.
We will see. We will. It will be. You'll find what you find in the notes if you go there. Thank you very much, Jason. Are we good to wrap up for now?
I believe we are. Yes. See you next.
Thank you for listening and watching. See you next time. Bye, Jason. Bye, everyone.
Bye.